Something is about to happen to the moon that no living person has ever seen. Not your grandparents, not anyone alive in 1945. Not a single human being walking the earth right now has witnessed this specific alignment in the sky. Because the last time it occurred, the year was 1860. The geometry that produces it requires centuries to repeat, and next week, it repeats. By the end of this video, you will understand exactly what is coming, why it is so rare, and why scientists are not just watching it, they are working through it. What is actually about to happen? Let me be precise about what is actually happening because this deserves precision. Next week, the moon will reach what astronomers call a major lunar standstill. That phrase gets thrown around occasionally in fringe corners of the internet, alongside a lot of other phrases that do not mean anything. So let me be clear about what it actually means before we go any further. The moon does not orbit Earth in a flat, simple circle. Nothing in space ever does anything simple, and the moon is no exception. Its orbital plane is tilted relative to Earth's equator by about 5 degrees and 9 minutes of arc. That tilt is not fixed. It wobbles. It precesses. Over a cycle of 18.6 years, the moon's orbital tilt swings back and forth, and at the two extremes of that swing, something measurable and dramatic happens to where the moon rises and sets on the horizon. At one extreme, called the minor standstill, the moon rises and sets within a relatively narrow band of the horizon, quiet, contained. Underwhelming, honestly, if you did not know what you were looking at. At the other extreme, called the major lunar standstill, the moon's orbital tilt adds to Earth's own axial tilt instead of partially canceling it. The result is that the moon swings across the sky in a dramatically wider arc than at any other point in the cycle. It rises farther north. It sets farther south. At high latitudes, it climbs higher in the sky than at any other time in the 18.6-year cycle. And at latitudes above roughly 61 degrees north, something extraordinary occurs. The moon does not set at all, a full moon that simply refuses to go below the horizon, a lunar midnight sun. That is not a metaphor. That is orbital mechanics producing a phenomenon that would have been genuinely terrifying to anyone watching without a physics textbook to refer to. Here is the specific timing. The major lunar standstill peaks in next week's window, with the moon reaching its maximum monthly declination, its farthest swing north of the celestial equator, during the same period as a full moon. That combination, peak standstill plus full moon, is rarer than either event alone. The full moon in a major standstill month rises at an azimuth, a compass bearing, that it will not reach again for another 18.6 years. But the precise coincidence of the standstill peak with a full moon near the solstice pulls the rarity out to something considerably longer. That something considerably longer is what puts us in genuinely uncharted human territory. Why no one alive has seen this. Here is the number that makes this real. The last time the major lunar standstill peaked in this specific configuration, with the geometry aligned the way it will be next week, was approximately 165 years ago. The year was 1860. Abraham Lincoln had not yet been elected president. The American Civil War had not started. Charles Darwin had published On the Origin of Species exactly 1 year earlier, and most of Europe was still arguing about it. The vast majority of the world's population in 1860 lived without electric light, without any way to photograph the sky, and without the mathematical tools to fully understand what they were seeing above them. Nobody alive today was alive in 1860, the oldest verified human lifespan on record, 122 years, belongs to Jeanne Calment of France, who died in 1997. Even she was born in 1875, 15 years after the last occurrence. There is not a single human being who has personal lived experience of this event, not one. And here is what makes that genuinely strange rather than just mathematically interesting. The 18.6-year cycle of the lunar standstill is short enough that most people alive today have lived through at least one complete cycle. You have probably lived through several. Minor standstills, major standstills, all of it cycling through while you were busy doing other things and not noticing, because nobody told you to look. So why is this occurrence different from the major standstill of 2006, the last one within living memory? Because the 2006 standstill, while real and measurable, did not produce the specific geometric conditions that next week delivers. The standstill cycle repeats every 18.6 years. The precise alignment of the standstill peak with the full moon phase and the proximity to the solstice does not repeat on that schedule. It requires those three separate cycles: the nodal cycle of the moon's orbit, the synodic cycle that produces full moons, and Earth's annual journey around the sun to line up simultaneously. Getting all three to converge takes much longer. Think of it like three clock hands on the same clock face. Each hand moves at its own rate. Getting all three to point in exactly the same direction at the same time requires patience. Specifically, it requires the kind of patience that outlasts every human being currently drawing breath. This is why the framing matters. It is not that the major lunar standstill is rare. It is that this major lunar standstill is a version of the event that none of us have ever seen. The science behind the geometry. To understand why the geometry is so specific and so difficult to reproduce, you need to understand how the moon's orbit actually works, and I promise this is more interesting than it sounds. The moon's orbit is tilted at about 5.1 degrees relative to the plane of Earth's orbit around the sun, which astronomers call the ecliptic. Earth itself is tilted at 23.4 degrees relative to that same plane. When you add those two tilts together at their maximum combined value, you get a moon that can reach a declination, a celestial latitude of about 28.6 degrees north or south of the celestial equator. When the tilts work against each other at the other extreme, the moon only reaches about 18.3 degrees, 28.6 degrees versus 18.3 degrees. That difference translates at the horizon into moonrise and moonset points that shift by a significant fraction of the entire visible horizon. From London, for example, the standstill moon rises and sets at points on the horizon that are dramatically further north and south than the moon anyone in that city has seen in living memory. From Edinburgh, the difference is even more pronounced. From northern Norway, the moon does not set at all. Now, here is the part that makes this complicated enough to produce multi-century rare alignments. The point in the moon's orbit where it crosses the ecliptic, called the ascending node, is not fixed. It moves. It completes one full backward rotation around the ecliptic in exactly 18.6 years. That is the nodal precession. And because the node is moving, the exact date on which the standstill peaks, the moment of maximum northward or southward swing, slides around the calendar over time. In some standstill cycles, the peak falls near the solstice. In others, it falls near the equinox. In most, it falls somewhere unremarkable in between. The solstice alignment matters because the solstice is when Earth's own tilt is maximally pointed toward or away from the sun, which sets the geometry of the sky at its most extreme. When the moon's standstill peak and the solstice coincide, the moon's position in the sky becomes as dramatically displaced from its average behavior as it can possibly get. Getting that coincidence right, standstill peak near the solstice during a full moon within a compact enough window to be genuinely distinguished from the merely close requires all three cycles to cooperate. They did not cooperate in 2006. The 2006 standstill peak fell in the autumn. The moon was doing its thing, but not in front of the most dramatic possible celestial backdrop. Next week, they cooperate. The moon is going to demonstrate what happens when you let the orbital mechanics fully express themselves without interference from calendar misalignment, without compromise. And the people who built Stonehenge, by the way, almost certainly knew this cycle. The station stones at Stonehenge are aligned to the major lunar standstill. The builders of a monument erected roughly 5,000 years ago had apparently tracked the 18.6-year cycle long enough to encode it in permanent stone. They did not have notebooks. They did not have telescopes. They watched the moon rise and set generation after generation, and they noticed. I find that humbling and slightly embarrassing, given how many of us cannot find the moon in a clear sky without our phones. What scientists are actually watching for now here is where this stops being a sky watching event and becomes something scientists are actively using. The major lunar standstill is not just visually dramatic. It has real scientific consequences for Earth, and this standstill peak is being met with more instrumentation than any previous one in history, which honestly is how it should be. The ancient builders of Stonehenge tracked this cycle using nothing but their eyes and a lot of patience. We have radar. Let's use it. Start with tides. The moon's gravitational pull drives Earth's tides, and the geometry of that pull shifts dramatically during a standstill. When the moon swings to its extreme declination, tidal energy gets distributed differently across ocean basins. Oceanographers have long suspected the 18.6-year nodal cycle leaves a fingerprint in sea level records, one that has nothing to do with melting ice or warming water. It comes from the moon changing how it stirs the ocean. NOAA tide gauge networks across 3 ocean basins are running extended logging right now specifically to measure that signal, and this standstill is their best shot at pinning it down for nearly 2 decades. Then there is the crust. The moon does not just move water, it physically deforms solid rock. GPS networks and gravimeters across Europe, North America, and East Asia are logging continuous position data through the standstill peak, hunting for the subtle shifts in crustal behavior that occur when the tidal forcing geometry changes. The data feeds directly into models of sea level rise projections and earthquake hazard assessment. Not abstract science, consequential science. And then there is lunar laser ranging, where observatories literally bounce laser pulses off retroreflectors that Apollo astronauts left on the surface. Facilities in New Mexico, Italy, and France are running coordinated campaigns through the standstill window, using the extreme orbital geometry to sharpen their measurements of the moon's parameters to their highest possible precision. None of this was possible in 1860. The instruments did not exist. We are the first humans to observe this event with tools capable of fully reading what it is telling us. The historical record, last time. This happened, go back to 1860 for a moment, because understanding what the world looked like the last time this happened is the clearest way to feel the weight of the rarity. The year 1860. The moon reached this same configuration in the sky, rising at the same anomalous compass, bearing climbing to the same extreme altitude, refusing to set over the same latitudes in the far north. And the people alive to see it had essentially no framework to understand it. In 1860, the scientific understanding of the moon's orbital mechanics was well advanced by the standards of the time. Urbain Le Verrier in France and John Couch Adams in England had already used mathematical deduction to discover Neptune in 1846, which remains one of the great intellectual achievements of any century. Newton's gravitational theory had been the foundation of celestial mechanics for nearly 200 years. So, the mathematics to describe the standstill existed, but the general public had no access to it, no context for it, and no way to learn what they were seeing was cyclical rather than alarming. What written records exist of the 1860 standstill? Essentially none, in the sense of deliberate documentation of the event as an event. Newspapers of the period did not routinely cover astronomical phenomena unless they were eclipses dramatic enough to require special viewing arrangements. The major lunar standstill in 1860 almost certainly passed without a single major newspaper in the English-speaking world explaining to its readers what they were witnessing. Go back further. The standstill before 1860 would have been approximately 1841 or 1842, and further back, 1822 or 23, and 1803 or 04, and so on, walking backward through time in 18.6-year steps. Each occurrence mostly undocumented, mostly unwatched with scientific intent, mostly passing unremarked. The exceptions are the ancient records. The alignment of Stonehenge's station stones to the major lunar standstill was identified in the 20th century by archaeoastronomers studying the monument's geometry. Similar alignments have been found at Callanish in the Outer Hebrides of Scotland, where the stone circle appears to have been positioned so that, during the major standstill, the moon appears to skim the tops of the surrounding hills and set within the circle itself. The people who built Callanish sometime around 2,500 years before the Common Era were doing something we would now recognize as science. They were tracking a long-period astronomical cycle using the horizon as their instrument and standing stones as their record-keeping system. The ancestral Pueblo people of the American Southwest also appear to have encoded standstill observations in rock art and architectural alignments at sites in Chaco Canyon, New Mexico. Research published over the last several decades has identified probable standstill markers at multiple sites, suggesting that cultures on opposite sides of the planet, with no contact with each other, independently recognized the same 18.6-year pattern in the moon's behavior. That convergence is not a coincidence. It is what happens when observant people watch the sky carefully enough and long enough. The cycle is real and visible and dramatic enough that multiple independent civilizations noticed it and considered it worth commemorating in permanent stone. And then, somewhere in the transition to modern life, we stopped noticing. The electric light came and the sky dimmed. The city came and the horizon vanished behind rooftops. The schedule came, and we stopped having time to watch a moon rise and fall over the course of a night. The knowledge that ancient monument builders encoded in stone became the specialized domain of astronomers and archaeoastronomers, people most of us never talk to. Next week, the sky is going to do something that those monument builders considered important enough to align their architecture around. Most people will not know it is happening. The bigger picture, what this tells us about the moon's future. Pull back even further, and the standstill becomes a chapter in a much longer story about the moon and Earth that is, depending on your philosophical disposition, either reassuring or deeply unsettling. The moon is leaving us. This is not a metaphor and not a prediction. It is a measured, ongoing fact. Every year, the moon moves approximately 3.8 centimeters further from Earth. That is about the rate at which your fingernails grow. It sounds trivial. Over geological time, it is anything but. The mechanism is tidal friction. The same tidal bulge that the moon raises in Earth's oceans also slightly distorts the solid rock of Earth itself. Earth rotates faster than the moon orbits, so the tidal bulge is always slightly ahead of the moon in its orbit. That slightly ahead bulge exerts a small gravitational tug that pulls the moon forward along its orbit. Pulling the moon forward means giving it more orbital energy. More orbital energy means a higher orbit. A higher orbit means a greater distance. The moon is being gradually pumped outward by Earth's own tidal response to the moon's gravity. The moon's current orbital distance, roughly 384,000 kilometers on average, is not what it has always been. 4.5 billion years ago, when the moon formed from the debris of a collision between early Earth and a Mars-sized body that geologists call Theia, the moon was perhaps 10 times closer than it is now. The tides it raised would have been catastrophic by any modern standard. Ocean waves driven by a moon 10 times closer would have been enormous. The length of a day on Earth was perhaps 6 hours, and the moon's gravity was the dominant influence on Earth's rotation rate. That ancient moon is gone. The moon we have now is already a pale gravitational shadow of what it was. And the major lunar standstill, the event that next week produces its most extreme version in 165 years, is itself a product of the moon's current orbital geometry. As the moon continues to recede, the specifics of the standstill cycle will slowly change. The maximum declination the moon reaches will shift. The visual drama of a standstill, the wildly displaced moonrise point, the extreme sky arc, the non-setting moon at high latitudes, all of it is a function of the moon's current orbital parameters that are slowly, inexorably changing. The major lunar standstill you can witness next week is not permanent. Nothing about the moon's behavior is permanent on geological timescales. We happen to exist at a specific moment in the moon's 4.5 billion year recession, a moment when the standstill is still dramatic enough to be visually striking, still geometrically extreme enough to produce scientific value, still close enough that the moon fills enough of the sky to matter. There is something almost poignant about that if you let yourself feel it. The ancient people who built Kallanish and Chaco Canyon were not observing a timeless fixture of the sky. They were observing the moon as it existed in their moment of geological time. We are doing the same. And in some distant future that no human will live to see, the moon will be far enough away that the standstill's drama will have faded. The cycle will still exist, but will mean less. And whatever civilization exists then will inherit a sky subtly but permanently diminished. Next week is not just an astronomical event. It is a timestamp, a marker of where we are in the moon's long farewell, how to watch, and what you will actually see now. Let us be practical, because you should actually go outside and watch this. The major lunar standstill is not visible through a telescope. That is not what you need. What you need is a clear horizon, ideally to the north and northeast, if you are in the northern hemisphere, and the correct night. The full moon during the standstill peak rises in the northeast at an azimuth that will likely surprise you even if you consider yourself someone who pays attention to moonrise locations. From most of the continental United States, the moon will rise noticeably further north than you have ever seen it rise in your lifetime. That is not an exaggeration. You have never seen it rise from that bearing before. From Scotland, northern Scandinavia, Iceland, Alaska, and northern Canada, the effect becomes extreme. The moon grazes the horizon, tracks along it, and at the highest latitude simply does not go below it for one remarkable night. The peak viewing window falls across the next several days, with the most geometrically extreme moonrise occurring on the night of the standstill peak. You do not need a precise time to the minute to appreciate it. Go outside on a clear night, face roughly northeast, and watch where the moon emerges above the horizon. Then find a friend who has a photo of a moonrise from a previous summer. The difference in the compass bearing will be visible. Binoculars are worth bringing not because they reveal the standstill geometry, which is a horizon phenomenon, but because the full moon in a standstill is high in the sky when it reaches its culmination, its highest point, and the surface detail at that altitude with a full moon illuminating it is genuinely beautiful. You will see the Maria, the dark ancient lava plains that early astronomers mistook for seas. You will see the bright rays of impact craters radiating outward across the surface like paint splatter on a dark floor. The crater Tycho in the southern highlands has rays that extend for hundreds of kilometers. From your backyard with a pair of 10 by 50 binoculars, that structure is visible. If you have a smartphone mount for binoculars or a basic telescope, the terminator, the line between the illuminated and dark parts of the moon's surface, is where you want to look during a gibbous phase. The shadows there are long and dramatic and reveal the actual three-dimensional structure of the surface in a way that the flat, full moon illumination conceals. A full moon is actually one of the worst phases for seeing lunar surface detail, because the sun is directly behind you from the moon's perspective and shadows disappear. But the days immediately before and after the full moon are extraordinary. Go outside. The event does not charge admission. It does not require equipment. It does not ask anything of you except that you look up. Here is the frame that matters most when you step back from the mechanics and the data and the historical record, and just let the scale of this sink in. Every human being alive right now is seeing the moon for the first time. That sounds like a philosophical provocation, but it is literally true. The moon we observe tonight is not the moon anyone will observe in 50,000 years. It is slightly closer than it will be then. Its tidal influence on Earth is slightly stronger. Its apparent size in the sky is slightly larger. The standstill it produces is slightly more dramatic. We are living through the moon as it is right now, in this specific moment of its long story, and that moment is genuinely unrepeatable. The major lunar standstill next week is the most concentrated expression of the moon being exactly what it currently is. The geometry that produces it is the geometry of this moon at this distance, with this orbital tilt precessing at this rate. Change any of those numbers, as they will change over geological time, and you get a different sky. People have been watching the moon for as long as there have been people. Some of the oldest art ever found, engraved bones and cave markings from tens of thousands of years ago, shows evidence of lunar phase counting. The moon was humanity's first clock. It governed the planting of crops, the timing of religious ceremonies, the navigation of oceans, and the organization of calendars in virtually every culture that has ever existed on this planet. We have a relationship with the moon that is older than writing, older than agriculture, older than cities. It is one of the few things every human civilization in history has had in common. And yet next week, the moon is going to do something that nobody alive has ever seen it do. That is not a small thing. In a world that often feels like every possible experience has already been had and documented and posted, here is a genuine first. A sky event no living person has witnessed in this exact configuration. No footage of it exists. No photograph from this precise geometry exists in any living person's personal experience. It has not been seen in 165 years. 302 active weather alerts, a Category 5 typhoon, an asteroid wave, a shifting tornado alley, a warming ocean. The news cycle is full of urgent things happening right now, and it will be full of urgent things next week too. The moon does not care about the news cycle. It has its own schedule, written in orbital mechanics and enforced by gravity, and next week that schedule produces something remarkable. You will not get another chance at this for nearly 2 decades. And the next time after that, and the time after that, the geometry will still be cycling through its 18.6-year rhythm, but the specific combination that makes next week unique will not return for another century or more. The people who built Callanish understood that some moments in the sky's long calendar are worth stopping for, worth walking to a hilltop for, worth recording in stone in the only permanent medium they had, so that someone 1,000 years later would know that people had stood here and looked up and understood that something was happening. We have better recording equipment now. We have the physics to explain every degree of the moon's arc, every second of the tidal forcing, every centimeter of its slow recession. What we sometimes lack is the willingness to stop and look. Next week, the geometry cooperates. The moon will rise from a bearing on your horizon that it has not risen from in your lifetime. It will climb higher than it has climbed since before anyone alive was born. At high latitudes, it will refuse to set. Nobody alive has ever seen this. Go outside and be the first.